recall that a relation is a set of ordered pairs. The inverse relation is the set of ordered pairs obtained by exchanging the coordinates of each ordered pair. The domain of the relation becomes the range of its inverse, and the range of the relation becomes the domain of its inverse. So all that's saying is that you're switching x and y. Okay, you're switching the domain with the range and the range with the domain. So you're switching x and y. Okay, so we're switching those x and y values. So in words, we have two relations are inverse relations if and only if whenever one relation contains the element AB, the other relation contains the element BA. So you see from here, this one was xy, right? Now this x value is your y value, and this y value is your x value. So you're just flip-flopping those points. So an example of that, A here, we have a point 1, 5. Okay, that same point, after I find its inverse, will be 5, 1. Okay, so this 1 just flips to the y spot, and this 5 flips to the x spot. Not so bad, right? Switch x and y. So we're going to do an example of that using coordinate points. So we have the ordered pairs, -8, -3, -8, -6, and -3, -6. Okay, so those are the coordinates of a right triangle. We want to find the inverse of this. Okay, so I'm going to add my bracket. Starting with -8, -3, we just need to flip-flop the values. Okay, so instead of this one, I'm going to start with -3 and then end with -8. For my next coordinate, I had -8, -6. It now becomes -6, -8. My last one here, I had -3, -6. Switch those values to get -6, -3. That would be my inverse of that relation. So we're going to see what that looks like graphically. So I want you to plot these first 3 points. Okay, so plot these 3 points first. So we have -8, -3, -8, -6, -3, -6. Okay, and you can connect all 3 of those points, and that they should create a right triangle once you connect that. Okay, so that's where that right triangle is. Then, I don't know if my other pen has ink in it. Next, I want to plot my inverse points. Okay, so next we're going to plot these inverse points. So we have a -3, -8, a -6, -8, and a -6, -3. Okay, so this new triangle here is the inverse of my first one. Okay, so I want you to kind of look at those. Now, I know this is making you remember real far back, but do you remember in geometry when we flip-flopped x and y, what kind of reflection that was? Over what? It wasn't over the x-axis or the y-axis. It was over something else. It's over the y equals x line. Okay, so the y equals x line is this diagonal line through the origin. So your inverse is going to always reflect over that diagonal line. So once I draw that dashed line in, can you see that reflection kind of happen between your points? So this point reflects over that line to get here, this one over here, and this one over here. So it's just reflecting over that y equals x line. So each time you make an inverse, it should look like that. It should look like it's reflecting over that diagonal line. Okay, so I'm going to write this out. Okay, so it is a reflection over the y equals x line, just so you have that in your notes. Okay, questions? Questions on finding the inverse of your points before we go into finding the inverse of a function? Do we have that all down? Yes? Ready to move on? Okay. So as with relations, the ordered pairs of inverse functions are also related. So we can write the inverse of a function of f of x as f inverse of x. Okay, you see this little -1 up here? That reads f inverse of x. Okay, so in words here, if f and f inverse are inverses, then f of a equals b, if and only if f inverse of b equals a. Okay, that's still just flip-flopping a and b. Okay, so your inverse, you flip-flop a and b. So example, we have f of x equals x minus 4, and the inverse is f inverse of x equals x plus 4. So if I were to evaluate f of 6, so I'm plugging in 6 to my original, I would have 6 minus 4, which equals 2. Okay, so my a value here is 6, my b value answer is 2. So I can flip-flop those in my inverse. So if I were to plug in 2 in my inverse, it should end up as 6. Okay, you're flip-flopping those values. So we are going to do some examples. I'm moving on to the back here. So when the inverse of a function is a function, the original function is 1 to 1. Okay? Recall that the vertical line test can be used to determine whether a relation is a function. Similarly, the horizontal line test can be used to determine whether the inverse of a function is also a function. So in our first function, f of x, we can use the vertical line test. Okay? Vertical line test to see if it's a function. If your vertical line only hits one point on that line, then it's a function. If it hits more than 1 point, it's not a function. Now, if I take the inverse of that, okay, say it was, this is an inverse, I use a horizontal line test instead. Okay, so I used a vertical line test on my original. You use a horizontal line test on your inverse to see if it's a function. Now with this one, if I were to do that horizontal line test, it hits 1, 2, 3, 4 points. Okay, so that would not be a function. Okay, so it hit more than 1 point. Does that make sense? All right, we're going to do some examples of finding an inverse. So example 2. We want to find the inverse of each function and then graph it so that you can see that reflection over that y equals x line. So in letter A, we have f of x equals x minus 3 over 5. Now just like before with our points, we want to flip-flop x and y. Now right now you can't see a y, right? F of x is just y. Okay, so I can rewrite this as y equals x minus 3 over 5. Okay, and I'm just going to switch my x and y value. So instead of y, I'm going to write this as x equals y minus 3 over 5. Okay, so in an inverse, we just switch x and y. From here, I just want to solve for y. Okay, so we're going to solve for that variable y. So how would I go about doing that? What's my first step? What should I do? Don't divide. Get 5 out of the denominator. How did I do that? That's right. Multiply. So I'm going to multiply both sides by 5. Okay, they cancel over here. And I'm left with 5x equals y minus 3. Okay, I have one more step to get y by itself. What should I do? Add 3. Okay, so I have y is equal to 5x plus 3. That's your inverse function. Now to show that it's an inverse function, I'm going to go back to this function notation. So right now this says f of x. My inverse, instead of y, should say f inverse of x. So I'm going to replace that y value with f inverse of x, and then equals 5x plus 3. Move that up a little bit. Okay, so here's my inverse. Now I want to graph both the original and the inverse. Okay, so to graph the original, if you want to, you can make an XY chart. Okay, find 2 points on that line and then we'll just connect them. Okay, so I'm going to plug in -7 because I know it'll work nicely. So if I plug in -7 for x, I get -10 divided by 5, right? What's -10 divided by 5? -2. Okay, another number that works nicely would be 8. So if I plug in 8 for x, right, 8 minus 3 is 5. 5 over 5 is what? 1. Okay, so you can just plug in these points to find 2 points on your line. So from there I can plot those. So I have -7, -2, and 8, +1. Okay? I know your line's not going to be perfect here because I didn't give you a ruler, but here's my line. That was pretty straight. All right, next, I want to plot the inverse. This one's a little bit easier. Okay, it's in the form y equals mx plus b. What's your y-intercept here? 3. Okay, so I can plot my y-intercept at 0, 3. What's my slope? 5. So I can go up 5 and right 1. Now, if you don't remember to do that, you can again make this XY T-chart. Okay, but if you do, great. Again, my line's not going to be super straight. But from here, you should see that it's reflecting those points over that x equals y line. Okay, do you kind of see that? If you were to draw in that diagonal line. Okay, questions on our first inverse there? Okay, do you understand my steps on how I did that? Switching x and y and then solving for y? Yeah? All right, then we're going to look at letter B. We're doing the same thing. So again, f of x I can just change to be y equals, okay, I have 3x squared. Okay, my next step is to flip-flop x and y because I'm finding the inverse. So now it'll read x equals 3y squared. Now again, I'm trying to get y by itself. Okay, so to get y by itself, my first step is to get rid of this 3. Okay, so I'm going to divide both sides by 3. So they cancel out here. and I end up with x over 3 is equal to y squared. Okay, y isn't by itself yet though. What can I do to get y by itself? You can take the square root of both sides. Now when I take the square root of both sides, this plus and minus piece comes in. Okay, so I end up with plus or minus the square root of x over 3 equals y. Okay, so when you take the square root of both sides, you have to add in that plus and minus value. Okay, now again, I want to rewrite this so it's in function notation again instead of y. So my inverse is f inverse of x is equal to plus or minus the square root of x over 3. Okay, now again I want to graph this. So first, graphing my original, again you can make your XY chart, find a few points here. So I am going to plug in -1, 0, 1, and 2. Okay, so if I plug in -1 for x, I have -1 squared, which is +1. Multiply that by 3. That's just 3. If I plug in 0 for x, what do I get? 0. If I plug in 1 for x, what do I get? 3. How about 2? Yes. Okay, so when I plug in 2, I square 2 to get 4. 4 times 3 is 12. So I can plot each of these points and connect them. Since it's a square, it's a quadratic, meaning it should look like a parabola. Okay, it is a parabola. So I have -1, +3, 0, 0, 1, 3, and then 2's 12. 12's way up here. Okay, so my parabola shape is going to be really skinny here, and then up. Can you see that? All right, for my other one, okay, my inverse. To find my inverse, all I did was switch x and y, right? Yeah? So can I just take my points right here and just flip-flop them? Right? So instead of -1, 3, I would have 3, -1. You can just flip-flop those x and y values. 0, 0 is going to stay the same. Instead of 1, 3, I'll have 3, 1. And instead of 2, 12, I'll have 12, 2. Okay? So you can just flip-flop x and y. That's all an inverse is. So from here, I can plot each of these. So I have right 3, down 1. I have 0, 0. I have 3, +1. And then 12, +2. But again, that one goes off. So with this one, it is sideways. Okay, it's a sideways parabola. So it's going this way on my graph. But again, you can see that it's that reflection over that y equals x line. So if you were to draw that line in, you would have these points reflected over that line. Does that make sense? Are you with me? Do you have any questions? No?